All right, so the next one we're going to do is the stoichiometry and thermochemistry, which you said it was numbers 1, 2, 4, and 5, I believe. So 2, 4, and 5 are all basically the same. So I'm going to do number 1 first. Okay. So my example says 2 moles of sulfur dioxide as a gas plus 1 mole of oxygen as a gas equals, after the reaction is complete, 2 moles of sulfur trioxide as a gas. All right, so that's the equation it gives me. And then it tells me when 15.5 grams of sulfur dioxide reacts with oxygen, 24 kilojoules is evolved. Now we know from before that evolved means, there we go. Evolved means released, right? So that means it's negative. So we're going to remember that in just a little bit. All right, so we got our equation. Now, what it's asking us to find is the value of the change in heat. All right, so to do that, the first thing we have to do is we have to convert this grams measurement into moles. All right, so to do that, I don't know if you remember this from Gen Chem 1, probably not, but we start with the grams that we're given. So it would be 15.5 grams of SO2, as we see in the words that it gives us. 15.5 grams of SO2, then we multiply it by 1 mole over how many grams are in that 1 mole of sulfur dioxide. All right, so this is called stoichiometry. I realize now that this is probably what you're having trouble with. It's just the whole concept of stoichiometry. But basically, all you do is to convert grams to moles is you take the grams that you're given and you do this little time sign, and then you write 1 mole of whatever you're given, whatever element it is. And then to find out what goes on the bottom, all you do is look at your periodic table. So I'm going to go to my periodic table. All right. Now, before we write something on the bottom, we have to understand what sulfur dioxide is. All it is sulfur and then 2 oxygens, right? That's simple enough. So if we look at our periodic table, there's going to be a little number under every single element. So for sulfur, it's 32.06. For oxygen, it's 15.999. And then since we have another oxygen, we have to do it twice. So all we do to find what goes right here is we add all these numbers together. All right, so it would be 32.06 plus 15.999 plus 15.999, which is going to equal 64.06 rounded. All right, so then we take the 64.06 and we're just going to put it right under here. All right, so all it tells us is that in 1 mole of sulfur dioxide, there are 64.06 grams. All right, if it was something like water, H2O, well, we look at that and we know water is 2 H's, right, plus 1 O. And then if we look at our periodic table, right under the letter H, there's going to be a number that says 1.008. All right, so that's hydrogen's number, 1.008. And since we have 2, we have to do it twice. And then since we have oxygen, we do the 15.999 again. So all you're doing for stoichiometry is you're looking at the number that's under the element on the periodic table, and then you just add them all together. So this is going to be about 18.01 grams. All right. So if the question had given us 15.5 grams of water, H2O, then we would write something like 15.5 grams of water is equal to 1 mole of water over 18.01 grams, right? Okay, so this is actually a pretty big concept in chemistry, and I probably won't be able to do it justice until I can see you in person, so we'll hit that whenever we get back together on Friday. But that's the basics. Just always make sure you got a 1 on the top, and then to find the number that goes on the bottom, you just split up the thing that it gives you. So it would be an S and an OO for this because it's SO2, right? Or H plus O because it's H2O. And then you just add all the numbers that are given to you on the periodic table together. You add them up, and you just put them right here on the bottom. All right. So we take that, and then we multiply it out. We do 15.5 times 1 divided by 6406. And you're going to get, after you do the multiplication, 0.242 moles. I better make some more room. 0.02 moles because these grams right here cancel out. You got grams, and then there's still moles left. So you get 0.242 moles as that answer. But you're not done with the question yet, so I'm going to move on to a new sheet of paper. We have 0.242 moles. And then the next step is we take that number that we just found and we plug it in to the rest of the problem that it gives us. So I'm just going to show you how to do it, and then hopefully on Friday I can actually teach you what's happening. All right, so if you remember, we look back at the question. It says when 15.5 grams reacts with O2, 24 kilojoules is evolved. And if we look back at our equation, we see we have 2 moles of this sulfur dioxide right here. So all you do to solve the problem is you're going to write 2 moles of SO2, because that's how many it gave you in the problem, right? There's a 2 right here. If this was a 3 or a 4, you do 3 or 4 moles of SO2, but since it's a 2, you write a 2, all right? Multiplied by 0.242 moles. That's what we just found from the last step we did, all right? And since moles have to cancel out, we take this and we put it on the bottom, moles and moles, you see that? And then on the top, all we do is we take the heat that it gave us, which would be 24 kilojoules, all right? So 2 moles times 24.0 kilojoules divided by 0.242 moles is equal to, after you do the calculation, the multiplication, and the division, you get 198.3 kilojoules per mole, which is what the question is asking for, kilojoules per mole. But you're not done, because if you remember, in the very beginning, we talked about how it said this word evolved, which means released, all right? So this 24.0 is actually negative 24.0 because it's released, right? So we can't forget about that when we're doing our multiplication. Otherwise, we'll get the answer wrong. So make sure this is a negative 24.0, which would make this negative 198.3. And that's how you do number 1 for the stoichiometry and thermochemistry.